Welcome. Today I would like to introduce you to reaction kinetics, and we will start with a handout. This handout is dealing with a simulation that we call a collision theory simulation. So this handout answers a number of questions, but the big question is, what factors determine whether or not a chemical reaction will occur? So you are going to do the simulation on your own. So you are not going to watch a demonstration by the professor. So what we are going to do is, you are going to do the simulation at home and then come to class just to discuss what you have done. You should be able to answer all the questions from this handout, but there are some questions that are not answered by the simulation. So if you can go down here, we see one question here. What does the term chemical reaction kinetics mean? You can get an answer to this question from the book. So the next part of the simulation deals with factors that affect the rate of a reaction. So we are going to deal with species, like we have A species and B species. We will add the 3A and 3BC and see what happens at low temperature, what happens at high temperature. Then we will add 14A and 14BC. We also want to look at the numbers, what happens to the chemical reaction as you increase the numbers. Let me bring up the simulation that we are going to work with. Not this one, but this one. Let's hope it doesn't mess itself up. So if I can enlarge this one, all right. So I am going to post a link to this simulation on Moodle. The first thing that you do when you open the simulation is to select single collision, that is here. Then also click here. This energy diagram will come up. The diagram has energy coordinate this side and reaction coordinate the other side. Now this line shows where the energy is at. You can raise the line to the midway here, or you can raise it above this hill, which we call activation energy hill, from here to up here. We can raise the temperature by pulling this one. So you pull this one up, you can see that the total energy line is moving. So we can put it midway here, or we can put it at low energy. So what you need to do for a single collision, like at middle energy, you pull this one up. I think I have released it too soon. Let me relaunch it. You can relaunch using this one. So let's say I pull this one up, somewhere middle energy, release this, and see what is happening. Is there a chemical reaction taking place? A chemical reaction will take place when that chemical bond breaks. If I can relaunch this one again, and then pull it the maximum, you can see what is happening there. You can see a chemical bond being broken, another chemical bond being formed. So what you want to do is to wait for it for some time until the collisions that are taking place are not breaking and forming chemical bonds, and you should be able to determine what type of collisions result into the formation and breaking of chemical bonds, what type of collisions do not result in any chemical reaction. So that's what you are going to write down on your handout. After this one, then you go to many collisions. So you click on the many collisions. Let me click again. Yeah. So from here, we're saying you have maybe 3A plus 3BC. This is our A, this is our BC. So you can just write 3 here. It's messing up. You can say all right, let me just say 3 here. If it's gonna work, and 3 here. So the 3 and the 3 I don't know why 3BC is not coming, but it's supposed to come. All right, yeah, when we move the cursor from there, the other 3 comes. Now we can decide to do this at low energy, which is now, and observe what is happening. Is a chemical reaction taking place? We can decide to raise the temperature. Now you can raise the temperature using this one. As you do this, the temperature is rising and the energy also is rising. So this one can be our medium energy, or we can raise it to high energy and see at each point are there chemical reactions occurring. We can also do the same for the number of molecules that we are having, 14, and see how much time does it take for a chemical reaction to occur. One other thing that you can do is to add a stopwatch. So you can decide, all right, I want to run this reaction maybe 100 seconds to see how much of the chemical reaction will occur, how many of these will change to products. If you do 3, how many of these will change into products at a specific time? So you can use this timer to help you deal with that. So basically, you are going to answer the questions from the handout using this simulation. You can also do rate experiments. Now you can go here. Let's say we have 3 of A, 3 of BC. Then we select the temperature that we want to do it, and then we can do an experiment.